Hello, welcome to today's lesson. We are going to tackle a special topic in elective mathematics. We are starting, and that topic is sets. So, set is a topic in elective maths that most students find it cool, but when questions come during WASI examination, they find themselves wanting because they lack some basic or actual understanding of what the concept entail. Also, because calculator can easily handle some of the operations for them, they rely on them, and then they are not able to answer some technical questions that are easy if you know the concept. So, what we are going to do before we even start the topic, the reason for all these difficulties that they meet is because they don't end up analyzing what they need to know before starting the topic. So every lesson that we are going to be learning, there is something called um, prerequisites, meaning things that we need to know before starting a particular topic, things that you need to know from previous topic before starting the, the next topic. So for this particular one, the set also needs some prerequisites. Prerequisites allow you to connect one topic to another. So I allow you to connect the dots for you to actually understand how things work, how the concepts interconnect. So as we are going to start with said, we have its own prerequisites as well. So let's start with the prerequisites. Let's get to our whiteboard. So the very first thing that you need to know before starting the topic is having a strong ground in multiplication table. So your multiplication table should be strong. Yes, they are found at the back of books, exercise books, and stuff. And the calculator can easily handle that. But then you yourself, as a person, you need to have a strong ground in your multiplication table. The next thing to also know is you knowing about prime numbers. You need to know your prime numbers. You need to know your prime numbers. So yeah, we need to know your prime numbers. So what are prime numbers? These are numbers that can have only two factors. There are numbers that have only two factors. That is one and themselves. Those are the factors that we have. Meaning these are numbers that can be divided exactly by one and itself without a remainder. We all know about the prime numbers, so we need to revise those concepts. The next critical thing is knowing your division rules. It's also a prerequisite for this particular topic. You know your division rule. Division rule, I mean, how to know mm, whether a number is divisible by 2, 3, 4, 5, 6, 7, 8, 9, and 10. Yeah, we are going to stop at 10. So the division rule for these basic numbers, these numbers, so meaning that we are going to see when they give us a number, how do we know that the number is divisible by this, by that, by that, by that? If you know your division rule, it will help you to easily do your prime factorization. Prime factorization. So if you know our prime factorization, then we need to solidify this concept with indices, indices, and also how to do expansion operation. Expansion operation. These are the prerequisites that we need to deal with before going on with set. So I'm not just going to state it, but I'm going to help you revise them. Or those who don't even know about it will actually learn new things. The multiplication table, I say calculator can help us, and then our there are our exercise books have them at their backs, so you can be referring to them from time to time. Yes. So prime numbers, you say they are number that can be divided by two. They have only two factors, one and themselves. So they include two, three, 5, 7, going. Yeah. So these are uh, prime numbers. The main thing that we're going to start like focusing on in this prerequisite section is the division rule. Division rule, these are methods or formulae or concepts that allow you to know whether a given number is divisible by either 2, 3, 4, 5, 6, 7, 8, 9, or 10. What we mean is that when they give you a number like this, so how do we know that this number is divisible by 2 without doing the division? How do we know that this number is divisible by 2, by 3, by 4, by 5, by 6, by 7 automatically? So if you know that this number is divisible by 2 or is not divisible by 2, then you can now proceed to with 3. You don't have to go and do the full division before realizing it. So division rule allow you to quickly detect it so that you don't use the wrong number in doing the division. So by that division, I mean getting the division exactly without a remainder. So yeah, let's start with the division rule. So something that is divisible by 2. How do you know that this number is divisible by 2? A number is divisible by 2 if the last digit, I said digit. So by digit, I mean, um, we see in our number system, and our number system, we have 10 digits. That's 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Any other number that you have in our numeral system is a combination of one or two or more of these. Something, for example, the number 10. The number 10 is a combination of 1 and 0. The number 25 is a combination of 2 and 5. 134 is a combination of 3 digits, 1, 3, and 4. So yeah, so that is digit. So a digit is a digit. Yeah, these are the 10 digits that you have. So when we are saying um so we have even digits and odd digits. Even digits are digits that can, so the even digits include 0, 2, 4, 6, and 8. These are the even digits. The rest are odd digits. So what division rule is saying for division by 2, a number is divisible by 2 if the last digit of the number, the last digit, the very last one is ending, or it's one of these, it's one of the even digits. If the last digit is either 0, 2, 4, 6, or 8. So looking at this example, for example, 732, we see that the last digit is 2. The last one is 2. And 2 is an even digit. So for that reason, 732 is divisible by 2. That is the divisibility rule by 2. That's how to detect. So going again, a number is divisible by 2 if it's ends with an even digit. We saw what a digit is, so we know the even digit. So once you see that, then the number is divisible by 2. Let's go with divisible by 3. Divisibility by 3. A number is divisible by 3 if the sum of the digits in the number, if the sum of the digits in the number is divisible by 3, is divisible by 3, or you can say is a multiple of 3. It's a multiple of 3. How do you say that? So let's still take the 732. So 732, we say it's a number divided if the sum of the digits. So the sum of the digits, meaning you are going to add all the digits. So we have 7 plus 3 plus 2. If you do that, you are going to get 12. So On our multiplication table, we know that 3 times something will give us 12, right? So that's why we say by it's a multiple of 3. Or we can easily say, oh, 12 can be divided by 3 to give us 4. So that's why it's it two ways. So what we have here is 732. Okay. Sometimes when we have two digits like this, what I do is that when I add the digits and we still have two digits, what we can do is that we can still continue the process, repeat the process 1 plus 2 to give you 3. For this particular digit, the result that you get, you can still add them to see, continue adding them and you get a single number. So the single number I have here is 3. So 3 is divided by 3. So it's very obvious. So the number 732 is divisible by 3. Yeah, that's about division for 3. So if I have 134, so if I add the digits 1 plus 3 plus 4, I'm going to get 8. And 8 is not divisible by 3, or it's not a multiple of 3. Therefore, the number 134 is not divisible by 3. Then we're going to, but if you want to check for the number 2, the number ends with an even digit. So the even digit here is 4. For that reason, it is divisible by 2. But divisible by 3 doesn't it's not divisible by 3. Let's get to divisible by 4. So for divisible by 4, what you have to do is that um the last two digits of the number. You see, when we were division by 2, we were like the last digit, right? But then when we are dealing with division by 4, you have to focus on the last digits, the last two digits of the number. We explain what a digit is. So yeah, the last two digits of the number should be divisible or a multiple of 4. We know the 4 times table. So let's take the 732. So if we have the 732, we check the last two digits, which is 32. 32. So 32, is it a multiple of 4? Meaning, is there something 4 times something that will give you 32 on our multiplication table? What do we have? So it's 4 times 8 give you 32. Therefore, this entire number is divisible by 4. Then this entire number is divisible by 4. That is how to detect it. So for division by 2, you just check the last digit. For division by 4, you check the last two digits. So if the last two digits is a multiple of 4, then the entire number is. That's fine. So if you had a 134, so when we have a 134, we see that the last two digits is 34. 34 is not a multiple of 4. 34 is not a multiple of 4. Are we okay? How? So sometimes you may not know, but what you have to do is that you know that 4 contains 2 times 2. So it contains 2 and 2, right? So one tricky thing, if you don't really know what the number is, or the 34, for example, is divisible by 4, what you have to do is that you take the last two digits, which is 34. I'll divide it by 2. So if you divide it by 2 first, you are going to get 17. Yeah, that's the first 2 inside the 4. So we say 4 contains 2 of the 2. The first 2 divide it to get to 17. But the second 2 cannot divide this 17, because 17 is not an even number. For that reason, since the 2 of the 4 cannot enter this number, therefore they cannot be their number cannot be divided by 2. But if we take the case of 732, we take 32, we divide it by 2, you are going to get 16 first. And then the second 2 from the 4 can still go into this and give you 8. Yeah, for that reason, since the all the two different 2's inside the 4 are divisible by this, divide the number exactly to give you no remainder, then the number is divisible by 4. Yeah. For divisibility by 5, we have to know, we have to see that the last digit of the number is either 0 or 5. Is either 0 or 5. The last digit of the number is either 0 or 5. So yes, these are the divisibility rules. So if you have like 732, The last digit is 2. It's not 0 or 5. Therefore, this number cannot be divided by 5. It's not divisible by 5. If you have 3, 2, 5, so the last number here is 5, which is 5 here. So therefore, you can divide by 5. So you just check whether the last digit is 0 or 5. Then you go ahead to divide by 5. That's a lot of concepts in the two. So we did 2, 3, 4, and 5. So let's go over the concept for that. For divisible by 2, the last digit of the number. For divisible by 2, the last digit of the number should be an even digit, either 0, 2, 4, 6, or 8. For divisible by 3, the sum of the digits, inside that number, the sum of the digits inside the number should be a multiple of 3. It means that when you sum all the digits, what you get, can you divide it by 3, or can you is some 3 multiplying something give you that particular answer? If you don't get it, you continuously uh, add the results. What if you add first? What you get? If you think that there are different digits and you can still add them, you add them and continue until you get a simple number. Now you see that a number that you are familiar with, that you know that is divisible by 3 or not. Yeah, that is about the 3. Now for 4, we say that the last 2 digits should be divisible by 4, or should be a multiple of 4. For that reason, what we have to do is that you know that 4 contains is 2 times 2. So we check if the two you take 2 first to see if 2 can enter. If that first 2 enters, then you check the other 2, the result that you get, if 2 can also divide it. That's either way. But if you know that the last 2 digits, you know you are very familiar that that particular number is a multiple of 4, then that's fine. And the last one we talked about was 5. If the digit ends with 0 or 5, then you know that that number is divisible by 5. Yes, we will continue, but now we need to take an exercise. We need the exercise to know whether we understand these concepts. So on to the next